everybody, and thank you for joining us on today's walkthrough demonstration of the Building Performance Database. My name is Tyler Grubbs. I'll be supporting today's webinar. We're going to get started in just a couple minutes to give anyone who would like to a chance to join. So sit tight, and we will be right back. Okay, I think we can go ahead and get started. My name is Tyler Grubbs. I am now going to turn the presentation over to Paul Matthew. Paul is a staff scientist and department head of whole building systems at Lawrence Berkeley National Laboratory, where he conducts applied research and market transformation activities on energy use in buildings. He is also, along with his colleague Travis Walter of LBL, also on today's call, who will be running the demonstration itself. Responsible for the development and ongoing support and maintenance of the building performance databases. So I don't want to take up too much more time from those two. So Paul, with that said, I will turn the floor over to you.
Thank you, Tyler. And again, hello, everyone. Thanks for taking the time to join this webinar. So in terms of what we'll be covering today, let me just advance my slide. There we go. We will first talk about what is the BPD and how it can help you, because we realize some of you may not be familiar with the tool at all. Then we'll take a good chunk of the time to do a demonstration that will be led by my colleague, Travis Walter. And then we'll wrap up with some additional information and resources and answer your questions. Speaking of which, you'll notice on your webinar panel, there is a questions panel there, so please enter your questions as they come up, and at the end we'll answer as many as our time here allows. Okay, so what is the BPD? It is the nation's largest publicly accessible database of the measured building energy performance. To date, we have over 1 million buildings in there, both commercial and residential, and we've gotten these from a range of different public and private sector data sources. In fact, we have over 70 sources in there right now. It also includes, for some subset of these buildings, we have asset and operational characteristics, such as system characteristics, types of HVAC and lighting, and how many hours it operates, and things of that nature. So who's the BPD for, and how can it help you? Really, the BPD was initiated, about 7 or 8 years ago now, and it was done to respond to a market need on the need for measured energy performance of buildings. And that's needed by a range of different stakeholders. So for example, if you're an energy consultant or you're a building owner, you may be interested in a question such as, how does my building compare to others in my city or state or climate zone or right down the street? And this is, again, classic, peer group kind of customized benchmarking. Or if you're an architect or engineer, you may be interested in a question such as, what is the range of site EUI for medium-sized office buildings in the upper Midwest? So you can benchmark and sanity check, for instance, your model results in new construction or major renovation and so on. But it's also for some other stakeholders. So for example, if you're an efficiency program analyst, you may be interested in questions such as, do buildings with feature X have higher EUIs than those with feature Y? Or what is the EUI trend in San Francisco or in other cities since 2015? And then also researchers and energy analysis tool developers are interested in a range of different questions, including things such as, if imagine you're doing some analytics on building energy consumption in the US generally, and you may be interested in how source UI, for instance, varies by building size or age or characteristics, other characteristics, and so on. So the BPD is really designed to be a data set that helps answer a range of these different kinds of questions using data that are, from a range of different data sources. I should also mention that the BPD is now referenced in ASHRAE Standard 211 for commercial building energy audits. And it's also required as a tool to be used in ASTM's standard for property condition assessments that are used at the time of a building when it's being refinanced, or rather financed or refinanced. So I'm just going to talk about a few features of the BPD itself. First, as I kind of mentioned earlier, it contains actual data on existing buildings. So it's not, for instance, simulated or as designed data on buildings. All the data are anonymized and mapped to a common format, and then they're cleansed with a set of cleansing rules that we developed, as well as deduplicated because sometimes buildings appear in multiple data sets, so we need to kind of work on that as well. The chart on the right, or the diagram on the right, shows you the overall structure. It's again fairly straightforward, conceptually anyway. We have these varied data sources, and really they really are very, very varied. I mean, they're in all kinds of different formats, different ranges of data, different data definitions, and so on. So the first kind of significant task is really to map them all to a standard common format. And often, by the way, when we do that, we lose, about 20% of the data records just because of ambiguities and so on. And then they run through our cleansing rules, and we put them in the BPD, in the actual database itself. The database has an API, that's an Application Programming Interface. And through that, we have a tool called the user interface. In fact, Travis will be demoing that in a second here. And that allows you to kind of slice and dice and look at the data in various ways. But also, and very importantly, the API can be used by third-party applications or researchers who want to kind of query the database in their own way. And so you don't have to go through the user interface that we have. You could also just query the database directly. A couple of caveats about the data. The data is not a national statistical sample. So in other words, we've not gone out and developed a sampling frame and a formal statistical survey to obtain a national statistical sample. It's essentially whatever data we can get and that people contribute. Having said that, we've actually done an analysis looking at how representative it is, and we'll say a little bit more about that after the demo. Also, and this is sort of, I know, a bit of a disappointment to some people, we often get the request, can we get all the individual records? And unfortunately, because of data privacy agreements that we have with the data contributors, we're not able to provide individual records unless they're already publicly disclosed. So for example, the benchmarking data sets from various cities are in fact already publicly available. So we provide a cleansed version of those data on the database itself. And finally, I want to say a little bit about this new version that we just released last month, so it's kind of still hot off the press in certain ways. In this version, we now have multiple years of data, which allow for longitudinal trend analysis, and you'll see that here in the demo as well. We've also updated the data with more recent energy data for many of the data sources that we previously had, and we've also added a couple new data sources that we were made aware of. The user interface has also had a significant update. In fact, it's been completely refactored, the code itself. We now have added this multi-year analysis feature. We've also updated the user experience and the look and feel. And also, we have now a partnership with Earth Advantage, which is a company that actually helped develop the early version of the user interface, has also developed this new version, and they will be taking primary responsibility for maintaining and further developing this user interface in the future, while Berkeley Lab focuses on the core database and the data set itself. Okay, with that, I am going to, let us go to the demo. Let me transfer control to Travis here in a second. Let's see. And of course, right before I seem to have lost my button to change presenter.
Oh, I can go ahead and assign him.
Oh, got it. I've got it. Yeah, I made it. Sorry. Sorry for that. And now, Travis, you should be the presenter. So. All right.
Okay. All right.
Yep.
Okay. Hello, everybody. This is Travis Walter. I work with Paul on the BPD, and I'll be running through a brief demo of the website. We start here at bpd.lbl.gov. I'll enter my sort of username and password, and this is where you would sign up for a new account. The first thing you see when the page loads is the sort of general layout of the website is on the right side. You have this section here, which is for sort of filtering down my data set to put different filters on properties of the buildings or their locations or their systems in order to narrow down and look at sort of a more specific peer group. And then on the left side are several plots that I'll describe in a little more detail of the data itself. And at the top of the page, you can see there's right now we're on the sort of explore page, which is really about looking at kind of one peer group at a time. And then there's also a compare page, which is looking at two different peer groups and how they relate to each other. So I'll just run through a simple demo where I filter down onto, I'll start with sort of one of these saved data sets, and some of these are examples that come in your BPD account when you create it. For example, there's one just with all buildings and all commercial buildings, then there's some that have particular types of windows or lights. I'll start with all the buildings, and you'll see that I have a counter up here in the top right, which indicates the number of buildings that filter returns. So I start with sort of just over 1 million for all the buildings in the whole data set, but now I'll narrow it down and I'll go over here and I'll look in this building classification piece, and then I'll go further down into the sort of commercial building types, and you can see there are several different types all the way from agricultural to laboratories to nursing homes. And just for the sake of example, I'll choose offices, and I'll choose all the different subtypes of offices. And you can see on the left side that my plots are updating as I refine my data set. You'll notice the counter here in the bottom is different than the counter above because the counter on the right side here at the top of my filters indicates all the buildings that match my filter, whereas this counter over here on the left side for the histogram, this one also is the buildings that actually have data for the thing that I'm plotting. So here I'm looking at a histogram for just all of the office buildings, and now I'll narrow down a little bit further by going to this section here, location and data source. And this is where, if I wanted to, I would choose a particular climate zone or maybe multiple climate zones. But for this example here, I'm just going to use this type ahead menu and put in a particular city. I'll just choose San Francisco, and you'll see that my plot is updated again. And then likewise, after location, I can look at sort of different properties of the building, like a floor area, number of occupants, Energy Star rating. And here we have, for numerical variables, there's a slider where you can move it just with your mouse, or you can sort of type in the numbers. And this is where I would say, oh, maybe I'm only interested in office buildings about 50,000 square feet or something like that. But for now, I'll leave that one off, and we'll just look at San Francisco office buildings. So that's my first data set. So moving over to the left side of the page, I'm going to say a little bit about the different plots that we have. The top one is just a histogram with the number of buildings in each sort of bin. And right now I'm binning the data by source EUI and kBT per square feet, but I also can choose other things like floor area or the year that the building was built. And this will give you an idea of sort of when what the vintages are of the buildings. And then you can see in this little lollipop thing here, 1924, this is the median for the variable that I'm plotting here. And you can see likewise the count in the bottom right corner of the histogram is updated, reflecting that fewer of the buildings actually have data for year built than they did for a source EUI that I started with. And then so moving on down past that, there's a scatter plot, and this is where I can look at sort of two different variables and how they relate to each other. In this particular example, maybe we'll look at How about Energy Star rating? And let's see what how that relates to, how about site EUI? And so as you would expect, sort of a higher Energy Star rating here on the horizontal axis tends to be related to a lower site EUI on the vertical axis. And here's a sort of crosshairs here, which indicate the sort of medians. And I can hover over and see the median Energy Star rating and site EUI. And then, so moving down past the scatter plot, this is the new plot that we just added recently. This is the multi-year plot. And so this is a particular variable here. I'm looking at source EUI on the vertical axis, and on the horizontal axis is time. So these are the years of source EUI for each building. So one particular blue line is an individual building, and you can see some of them are really high and some are low, and some are bouncing all over the place, and some are flatter. Sort of when the cloud is more dense, like that's kind of where more of the buildings are. And then to sort of summarize the information here, we have these darker lines. These indicate the quartiles, so the 75th percentile, the median, and the 25th in a particular year. And this is a good way to sort of look at trends over time and see kind of what the peer group is doing. In this particular case, it looks like the median and the quartiles are sort of trending downwards relatively slowly, but sure enough, it looks like they're going down to me. And then lastly, below that is the table, and this is just how to look at statistics of your peer group, but split down by a particular variable. Here it is defaulted to facility type, and I can see that for the different office types, it will tell me how many of those office types are in my data set and what the medians and means are. And then if I want to, I can split it up in a different way, and maybe I want to look at it split into floor areas, and I can see that maybe the median, the mean for sort of bigger buildings is seems to be a little bit larger than the mean for smaller buildings, but not that clear. I can download this as a CSV file if I'd like to, and I think that kind of sums up the plots for the Explorer page. So now I'll go over and I'll switch to the compare page, which is where I'll look at a second data set and I'll figure out how it compares to my original data set. So scrolling back to the top here, I've got on the right side now, you can see that below my sort of blue filter settings for my first data set, I've got a whole new panel here in orange, which is for my second data set. And so for this one, likewise, I can choose from sort of my saved data sets that I have made myself, or I can choose from the example data sets. And you can see by just to sort of clear the slate, I'll go to all buildings, so I have everything, the full 1 million+ buildings, and then I'll whittle down into a sort of a more detailed peer group. So just to mirror what we did before, I'm going to choose all office buildings. And then I think what I'll do is for location, instead of San Francisco, I'll choose another city, and we can sort of see how the two cities compare. So I'll click on location here, and I'll open up my city, type ahead, and how about New York? And so now my counter should update for my orange data set. It looks like I have around 1,500 buildings in office buildings in New York. And then you can see over here on the histogram on the left side. Now there's two different histograms, an orange one and a blue one. The orange one is for the second data set, and I can see their medians, 110 versus 184. And likewise, I can change the variable I'm plotting, and you can see also that I have two different counters, one for each of the data sets. There's a scatter plot as before. There's a multi-year line plot where you can see sort of both the orange cloud and the blue cloud, and you can see sort of what the trends are and maybe how they're different. You can see there's red lines here for the quartiles for the orange data set, and the darker ones, the black ones, are for the blue data set. And here the median for sort of both cities seems to be decreasing, but it looks like the median for the first data set is consistently lower than for the New York data set. And then the final difference, or the final plot here, is what's different about this compare page than about the explore page. And this last plot here is it's a histogram of kind of the differences of EUI between the two data sets. I say EUI because here I've selected source EUI, but again, you can choose other variables to analyze here. And this is the differences. So sort of a positive number on this difference would indicate that the second data set has a higher source EUI than the first one. And as with the other histograms, this histogram has a little circle here indicating the median is 67. So that would say that kind of the median difference between the two is that the office buildings from New York have a 67 kBT per square foot higher source EUI than the ones do in San Francisco. And you can hover over parts of this difference histogram, and it will essentially give you the kind of area under the curve to the right of the bin that you've selected. And it will tell you sort of how likely is it that a building in New York has a certain percent higher EUI than one in San Francisco. So I think that pretty much does it for the plots. To summarize, there's kind of the right side is where you adjust your filters and choose your data sets. The left side is the different data visualizations. There's the explore page at the top for the explore page for one data set and the compare page for two different ones. And then the last aspect, I suppose, is in the very top right corner here with this 3 horizontal lines. This hamburger menu is just some sort of general stuff about this site. This is where you would report a bug if you found it, and we have a guided walkthrough to sort of help teach you how to use the page and to go over the filters and all that stuff. We've got a couple of maps that show how many buildings are in the data set and which states have a lot of data and which ones don't. You might have guessed what this map would look like. And then the last sort of interesting thing on this page is that we have this list of files here, which is the public data sets. So some of the data sets in the BPD are publicly available, and if they are, then we've put them here. We've cleansed them according to our rules and put them into our format, but then we've put them here on the website so you can download them and analyze them as you see fit. Mostly these are benchmarking cities, but there are a couple others that are different. And I think that about does it. So that's the site, and we hope you will try it out.
Thanks, Travis, for that demo. And I would now like to just wrap up with a little bit of additional information and some resources to get you going on using the BPD. So I alluded earlier to the fact that the BPD is not a national statistical sample, but of course we often get the question whether the BPD, how representative the BPD is. So what we did was that we compared it to CBEX, and the way we did this was that we analyzed various combinations of building type and geographic region, and specifically we used census division. In fact, I think we did a total of about 180 such combinations. And the short answer really here is that some groups are fairly well represented and some are not. And I'm showing you two examples here of both those cases. One on the left is for education buildings in the West South Central Census Division, and the one on the right is office buildings in the Pacific Census Division. The green histogram represents CBEX, so the National Statistical Sample essentially, and the purple is the BPD. So as you can see, for the image on the left, the education buildings in West South Central, the BPD is significantly shifted. This is for floor area in particular. BPD has larger buildings, so it's not very representative, at least as it relates to floor area. The one on the right is actually for site energy use intensity for office buildings in the Pacific, and actually there's a pretty good overlap between those two histograms. And you'll see that the median are pretty close. For BPD is 53. KBD use per square foot, and for CBEX it's about 51. So it's just about a 4% difference in EUIs. So if you look across all those different 180 peer groups of these combinations of building type and the census division, that's what you're seeing plotted here. The image on the left is for floor area. It's showing you the median values or the 50th percentile values of those floor areas. So if the BPD and CBEX was perfectly representative of exactly what CBEX is, all those dots would line up along that blue line. As you can see here for the image on the left, the BPD basically has larger buildings. And you can see that with the cluster of dots above the blue line. The image on the right is essentially the same information, but for site EUI. And here, I guess the good news is that we did not find a significant bias. So for example, some people thought that maybe we'd have more efficient buildings, but that's not necessarily the case, and we don't see that bias. Now, having said that, there's still a lot of scatter, as you can see in the plot. So for some peer groups, you see that the BPD may be showing more efficient buildings and some less. The details of all of these are available in a technical report that you can download and take a look at. So if you're really curious about how representative the BPD is for a particular building type and census division, you can go and see that in that technical report. Okay, so wrapping up here again, I did again want to highlight this point about the fact that we have an API, an application programming interface for tool developers and researchers. It has all the endpoints that you saw in the user interface for histograms, scatter plots, and line plots, and tables, and the difference histogram. In addition, we also have an endpoint there that allows researchers to run custom regression analyses. Because again, this is to support researchers who say that we'd really love to have the individual records of the building so that we can run our own kinds of regressions. And of course, since we can't do that, we said that, well, if you can specify the regression equation that you're trying to generate, with the left-hand side, the dependent variable, and the various independent variables on the right-hand side, you can specify that via the API. We'll run the regression, kind of inside the wall, as it were, and then return the regression results back through the API. So that's a particularly useful function, I think, for researchers. For the API, it does require a license, so we have both evaluation and commercial licenses available, and we're happy to say that we've had about 75 licensees to date. The chart on the right shows you, or the image on the right shows you one particular example. This is Lucid developed a tool called benchmarkmybuilding.com, and they use the BPD API. So that's really it. We'd encourage you to log in at bpd.lbl.gov to use that user interface that you saw. If you want more general information about the data or how to contribute data and so on, there's the website for that, bpd-info.lbl.gov. And if you'd like access to the API, send us an email at this email address listed here, and we can get you set up. And we really welcome your feedback. How does the BPD help you or not? What are new features that you might like to see as well? And I would be remiss if I did not end with a pitch for more data. The BPD really does rely on data contributors. So if you have a data set that you'd like to contribute and add to the BPD, let us know. If you're concerned about anonymity or confidentiality and so on, rest assured that, again, all data are anonymized. We don't have any identifying information in the BPD. We strip that all out before we put it into the BPD. And in return for your contribution, you will receive a cleansed data set with custom analytics as well. And with that, I think we're done. Thanks again very much for taking the time out of your day to listen to this webinar, and we will be happy to go to questions.